Namaste, sir.
சரி என்ன அன்னைக்கு தான் சார் ஓகே தம்பி இதுதான் ஒண்ணு What is that? What is Hey, wait, அது HDMI டா. இது சம்திங்
Namaste, sir. Sir, please join meeting, sir.
Hello. So this is Raghav. I think you're audible. Just give me a minute.
Okay, sir.
I don't know what it means. We have to put on here.
Sir, am I audible now from the meeting?
Yes, sir, you are audible now, sir.
Yeah, is it fine now?
Wait.
Yeah, good afternoon, students. Am I audible?
Yes, sir.
Yeah. So just wanted to meet you all. Remember, I came last month. Yeah. So I think I informed you about the app, right? Students, am I audible? Can you
Yes,
just give me
sir.
a thumbs up if I'm audible? I'm not able to hear from you, sir. Perfect. Okay. So I just wanted to inform you about the app. So when I came for the last time, I told you about the app and the recorded videos present in it, right? You all remember that?
Yes, sir.
Yeah. So access has already been given. Okay. I was assuming that you got the messages, but I see that the apps are not yet downloaded from your side. Okay, you can start downloading it and start using it. Okay, just wanted to give this announcement. So as soon as you go home, the first thing that you can do is you can download it, and the videos are already present in it, and you can start making use of it. Is that point clear?
Yes, sir.
Yes, perfect. Okay, okay. So
Sir.
Adarsh sir will take over. Yeah, please tell me. Please tell me.
The login credentials.
So you have to log in with with your mother's number. So whatever number is given, right? So you have to use you have to log in with your mother's number. Okay, you would have given during the admission time, right? That is the number with which we have given access for. If at all you have any issue, right, you please let the respective coordinator to know, the teacher who is responsible for the class to know, and we'll sort out the issue through them.
Okay, sir.
Okay, yeah.
Thank you.
Thank you so much. And Adarsh sir will take over from here.
Thank you,
I'll
sir.
see you all. Bye.
Bye, sir.
Yeah. Thank you.
Yeah. Hello, everyone. Am I audible? All right. Can you see the screen?
Yes, sir.
Okay. So till the last class, we did some problems related to the motion in a straight line, and today we'll be starting with motion in plane. That means motion in 2 dimensions. Okay, dimensions means what? Basically, we need 2 axes to represent or define the motion. For example, let us say that we are moving in a straight line. We are moving in a straight line. Straight in a line or a same line. Yeah,
So your voice is breaking, sir.
go on. Any doubt?
Sir, your voice is breaking, sir.
Voice is breaking. All right,
Yes, sir.
1 minute. Is it fine now?
Yes, sir.
Yes, sir. Fine,
All
sir.
right. So basically, we required only 1 dimension or only 1 axis to represent the motion in a straight line. This was motion in a straight line. But motion in a plane requires 2 dimensions. 2 dimensions means what? You require simultaneously either x or y or combination of any 2 axes to represent the motion. For example, like this. At a certain change of point of x, there is a different change in y. So you cannot represent it in a single line or single axis. Can you tell me how many axes are required to represent this motion? Can you tell me how many axes are required to represent this motion in this oblique manner? Anyone please answer?
Sir, can you repeat the question? Sir, can you
How
repeat the question?
many axes are required to define this motion? Question is, how many axes are required to define this particular motion which is moving in this oblique line?
X and Y, sir. 2 axes, sir.
2 axes. No, only 1 axis is required. See, coordinate system is like this. This is as per our convenience. I can make the coordinate system like this also. This is my coordinate system. That is based on the observer, whoever is observing. So again, I can represent this line in a single axis. So wherever is a straight line, whether it is oblique, straight, upward, going downward, going leftward, going rightward, doesn't matter. It just depends whether it is straight or not. If it is curved, it requires 2 axes. If it is not curved, it will require only 1 axis. So only 1 axis is required to define this particular motion. Okay, motion in a plane, the best example is you are throwing a ball obliquely. You are throwing a ball obliquely upwards, and it will travel some distance like this and then come down. There are some properties related to it, but before that, we need to study some vector quantities. We have studied and we know that what is vector quantity, but we need to focus on the calculations related to the vector quantities. All right. So what are vector quantities? One more thing, from tomorrow you'll be studying these things, the theories you'll be studying from the app itself. You'll have to get that access there, and you'll be studying the theory part from the app itself. And before you'll be completing this portion before in the app, and the next class will discuss the questions related to it, the doubts related to it. All right. So theories will not be there from this side. Theories will be there from the app itself. So please focus on that. Okay. So vector quantities. What are vector quantities? Vector quantities require. Vector requires both magnitude
And direction.
and direction. So this was the theoretical part behind it. This was the theoretical part. What is the actual thing? The actual thing is that we need to like add or subtract vectors. And vectors does not get addition, subtraction like algebraically. They have vector laws of addition. And that is different from the algebraic addition. Okay, so we have to focus on that. First of all, if we write A vector and we write B vector, so we cannot add any two vectors anyway. Their addition is different. Their addition gives the result. For example, there is a man. Okay, he has two hands, and one has on one side of this hand is being pulled by one man. Another side of his hand is being pulled by another man. Where will he go? He won't go to any of the sides. He'll go straight between them. So there was a force F1 this direction. There was a force F2 in this direction. So when you add F1 plus F2, because both the forces acted on the same body, so we have to add F1 plus F2. The resultant will not be in the direction of either F1 or neither F2. It will be somewhere in between. That is called the resultant. What was the net effect on the forces or net effect of the vector you are applying? That is called the resultant vector. Resultant vector has different magnitude and different directions. It can be along the directions of one vector, but that depends. Generally, for a resultant vector is something that we have to calculate. Okay, so for example, first law of addition. One more thing, 1 minute. So basically, we have vector laws of addition. And we have two laws related to it. One is triangular law. Triangular law. What is this triangular law? So triangular law says that if we represent one vector along this side, another vector along this side, so third vector will be in the opposite direction, that will be constituting the resultant. That is the A vector plus B vector. A vector plus B vector. So A vector along this side, B vector along this side. So line joining from the initial point of A to the final point of B in this particular direction will be your resultant vector. Okay. And now you'll ask me, sir, how we can represent any two vectors like this? So we can really represent any two vectors based on this. For example, if this is A vector and this is B vector. So say, sir, these two vectors are not related or represented as this triangular form of addition. But can you tell me, can I laterally shift the vectors? See here carefully. If I take this vector, okay, if I take this vector and I shift it here, did the magnitude get changed? Yes or no? I shift it here. Did the magnitude get changed? Anybody?
No, sir.
No. Did the direction change? What was the direction here earlier? If it was here, what was the direction? Eastwards?
Yes,
And
sir.
what is the direction? What is the direction now?
Eastward, sir.
So neither the magnitude changed, neither the direction changed. So did the vector get changed?
No, sir.
No. So we can laterally shift the vectors. Got it? We can laterally shift the vectors.
The vectors.
Now see here, I took this vector now, and I took it here. So did I change the vector?
No, sir.
Now can I find the resultant by joining the initial point and final points like this?
Yes, sir.
So this is the vector law of addition.
Yes, sir.
This is the representation of vector. Okay, this is graphical way to find the resultant of vector. For example, if you have a vector this side, let us say 5 centimeter vector. Okay, representation of vector is this line arrow. This is the tail part. This represents the magnitude. And this head part, the arrow represents the direction. This is the representation of vector. Okay, so I can represent any two vectors as this way. So this is called triangular law of addition. According to this law, if you represent this, one more thing. This is vector A, this is vector B, and now we'll be calculating. This was the graphical method to find the solution. Now the theoretical method. Let us say the angle between A vector and B vector. Angle between A vector and B vector is theta. Okay, I shall draw it in a better manner. 1 minute. This is vector A, and this is vector B. Angle between vector A and vector B is theta, right? Now see here, what this length will be. Can I say sine theta as, let us say this length is x, x upon B vector? Do you agree?
Yes, sir.
So x will be what? B vector sine theta.
Yes, sir.
And let us say this is L. So L, can we take cos theta as L by B vector? Right?
Sir, we can understand the
So-
cos theta is equal to L by B vector, sir. Can you repeat that?
Or
Please.
what is cos theta? Do you know that? What is the ratio of cos theta?
Adjacent by hypotenuse.
Base upon hypotenuse?
Yes, sir. Yes, sir. Yes, sir.
So this is the base and hypotenuse. This length is the hypotenuse. This is B vector.
Yes, sir. Yes, sir.
So now can we represent cos theta as L by B?
Yes, sir.
Got it?
Yes, sir.
So from here, L will be what? Can I write L as B vector into cos of theta? Right?
That's 2 minutes. Excuse me.
Okay, sir.
Fast, Amresh, Ganesh, Kananita, Kaushik, Manish Kumar, Nidhi, Dina, who passed outside. For A section, Yashwant, Gopala Krishnan, Veda, Vetrivel. Who passed?
Excuse me, sir. You can continue.
Okay, sir. So we can write L vector as B vector into cos of theta. Now see there in this triangle L, or I can write it some other way, P, this point Q and this point R. Can I apply Pythagoras theorem? Applying Pythagoras theorem in triangle PQR. In triangle PQR, it is PQ square plus QR square is equals to PR square. Do you agree with this? PQ square plus QR square is equals to PR square. Right? So what is PQ square? What is PQ? Can I write PQ as A vector plus L length whole square? QR is X whole square. PR is the resultant. This side shows the resultant according to triangle law of addition. So resultant whole square. Do you agree with it?
Yes, sir.
Right? What is L? Instead of L, can we write B cos theta? And instead of X, can we write B sin theta? So it is A plus B cos theta whole square plus b sine theta whole square is equals to r square. If you expand this, you'll be getting r as under root of a square plus b square plus 2ab cos of theta. This is the resultant of two vectors. Whenever we say a force is acting on a body 5 Newton eastwards, another force acted on the same body 10 Newton westwards. So we'll have to calculate the resultant of the force with this formula because force is a vector. Whenever we have to calculate the resultant of the force, we need to work on this formula.
Okay, sir.
All right.
Yes. A plus.
We need to and theta between the two. And this is
Okay.
just the magnitude here. We need to put it written. Shall we move on? If you have,
Yes, sir.
shall we move on? If you have written.
Yes, sir.
Next, parallelogram law of addition. Parallelogram law of addition is quite similar to the triangular law of addition. It says that if you can represent one vector this way, another vector this way, the resultant of the vector will be along the diagonal of the parallelogram. You'll have to form a parallelogram, or you can do it like this. 1 minute. If you can represent one vector this way, another vector the adjacent side of the parallelogram. So if you form the parallelogram, the diagonal of the parallelogram will give you the resultant. This is the parallelogram law of addition. This is A vector, this is B vector, and this is the resultant vector. This is what being said by parallelogram law of addition. That says that if one vector is represented along, another vector is represented as the adjacent side of the parallelogram with the one vector, the resultant of the vector will be the diagonal of that particular parallelogram. Understood? This is the statement. Got it or not? Again, from here, if you do the calculations by taking the angle and all, this is angle theta, this is r cos theta, sorry, r sin theta, this length will be r cos theta, like that. Sorry, this is b cos theta. 1 minute. This is b cos theta, and this is b sin theta, and this is b cos theta. So again, the same calculations will go on and get the resultant r vector as under root of a square plus b square plus 2ab cos of theta. Okay, did you write the squares here? Yeah. A square plus b square plus 2ab cos of theta. Same thing, same result will come. Got it? One more thing. Now, this was the magnitude of the resultant. How will you find in which direction the resultant is acting? Okay, in which direction the resultant is being acted? That is what you have to find. Okay, so let us say that resultant, it has an angle of alpha. I'm drawing it again. This is my A vector. This is my B vector. And this is my resultant vector. This is my resultant vector. So let us say that resultant vector is at an angle of alpha. Resultant vector is at an angle of alpha. Okay, from A vector. And A is a vector whose direction is already known to us. A is a known vector. And the resultant vector is an angle alpha to A. So we can represent it like this. See here. This will be B cos alpha, and this length will be B sin alpha. 1 minute. I'm telling you again. See here. Focus on it. I'll have to draw it in a better manner so that you understand. This is my B vector. and this is my A vector. I am drawing it with the parallelogram law. So according to parallelogram law, the diagonal will be my resultant. Yes or no? Say yes or no. Right? Put a thumbs up if you agree.
Yes, sir.
Right? All right. So opposite sides of the parallelogram are same. If this is B vector, this will also be B vector. Yes or no?
Yes, sir.
All right.
Yeah.
So now see here.
Sir.
If I draw a line here, if I take this triangle PQR, see here PQR, and this angle is theta. So this will be what? B sine theta. Because if you put sine theta, what will you write? Let us say this is X. If you say this is X, this length is X. So sine theta is what? X upon B. So from here, X is what? B sine theta. Again, let us say this is L. So cos theta is what? L upon B. So from here, L will be what? B cos theta. Right or wrong? Till here, yes or no? Tell me. Tell me yes or no.
Yes, sir.
Girl side, are you comfortable with this? All right, all right. So this is the angle alpha with which the resultant is there from any one vector. I could have taken this alpha from B vector also because B is also known to me, but I'm taking from A. So can I write tan alpha? Tan alpha as QR upon PR. Tan alpha is perpendicular upon base. So can I write it as QR upon PR? Everyone
Yes,
say
sir.
yes or no.
Yes, sir.
Right? What is QR? QR is X. X means what? B sine theta. B sine theta. And then PR. What is PR? PR is A plus L. And L is what? B cos theta. So A plus B cos theta. So this is how the angle is represented. B sine theta by A plus B cos theta. So we will say that the resultant will be at an angle alpha from A vector. And that alpha will calculate from here. This is how we represent any vector. This is the direction and that is the magnitude. R vector 1, that formula is magnitude, and this is the direction we calculate from any of the known vector. And this is how we represent any vector. Did you understand it or not?
Okay, sir.
Tell me if there is any kind of doubt. Okay, one thing there to remember it. I'll give you a mnemonics to remember it. See here. Tan is what? Sine upon cos. Sine upon cos. So first sine theta will be upwards, cos theta will be downwards. Now one more thing. If you are calculating alpha of the resultant from any one vector, so that vector will not contain the cos or sine. That vector will be left alone. If you are calculating this alpha from beta, so it will be A sine theta by B plus A cos theta. So like this you can remember. First you have to put sine upwards, cos downwards. Then the angle from which you are calculating the vector, that vector will not contain the theta. Understood? This is how you can remember it easily. Write it down. This is really important. Yeah. Any doubt?
No, no, sir.
All right, write it down. We'll be solving some questions related to it now. Written, everyone?
Yes, sir.
All right. Shall I change the slide?
Yes, sir.
Okay. Coming to a question. Try to solve this. Question says that.
Sir.
Yeah. Go on.
Sir, can you please write it a little bigger, sir?
All right. Okay. Question says that first of all, let us start me with a basic question. A body. Can you see this? Is this fine?
Yes, sir.
A body is simultaneously given two velocities. All right. One 30 meter per second. Velocities means vector due east. Then another 40 meter per second due north. So you have to find the resultant velocity. Find the resultant velocity. Do this.
Sir. Sir.
Yeah. Any answers?
Answer 50 meter per second, sir.
Very good. It is 50 meter per second. How did you get it? So resultant is under root of a square plus b square plus 2ab cos of theta. So if one is going towards east 30, another towards north 40. So angle between them is 90 degrees. So theta is 90 degrees. It is 30 square plus 40 square plus 2 into 30 into 40 into cos of 90. Cos of 90 is 0. So this whole term gets to be 0. So it is under root of 30 square plus 40 square. That will be 50 meter per second. Everyone understood or not?
Yes, sir.
Shall I change the slide?
Yes, sir.
Okay. Next question. Two forces whose magnitude are in the ratio 3:5. 3:5. Give a resultant of 35 Newton. If the angle of inclination be 60 degree, calculate the magnitude of each force. Do this.
Sir.
Yeah. Any answers?
Question not visible, sir.
Okay, I'm reading it again. two forces whose magnitude are in the ratio of 3:5 give a resultant of 35 Newton. Two forces whose magnitude are in the ratio of 3:5 give a resultant of 35 Newton. If the angle of inclination be 60 degree, you have to calculate the magnitude of each of the forces. Is it fine? Do it now. Any answers?
Sir,
Yeah, go on.
15 and 25 Newton.
15 and 25 Newton. That's correct. Good. So it is resultant is 35 Newtons given. Theta is 60 degrees. Okay. So resultant is equals to under root of p square plus q square plus 2pq cos of theta, where p and q are any two dimensions. Now see here, p by q is given to us 3/5. Okay, p by q is given to us, that is 3/5. So if it is in a ratio, it has been cancelled by the same amount. For example, how do we find a ratio? How do we find a ratio? If we want to find the ratio of 15:10, so that will be 3:2. Why? Because we divided both numbers with the same number, that is 5. So if we multiply both numbers with the same number, that will be getting the exact value. We'll be getting
Yes,
the exact value. So that's what we do. We take P as the first as 3x, second Q as 5x. Okay, so put it here. 35 is equals to under root of 3x whole square plus 5x whole square plus 2 into 3x into 5x into cos of 60 degrees. So when you solve it here, it will be 9x square plus 25x square plus 30x into root 3 upon 2. If you solve this, you'll get x is equals to 15 and 25, because this will be a quadratic equation, right? Okay, very good. Last question for today, then we'll be moving further.
sir.
Next question says that, yeah,
Cos 60 is 1/2, sir.
oh sorry, yeah, this mistake was there. 1 minute. This is 1/2. Yeah, we'll calculate it, get 15 and 25 only. Next thing. Next question. Two forces equal to P and 2P. Two forces equal to P and 2P. Sorry. Equal to P and 2P. Two forces equal to P and 2P act on a particle. Okay, act on a particle. If the first be doubled, listen, this question is very important. If the first be doubled and the second be increased by 20 and second be increased by 20, the direction of the resultant is unaltered. The direction of resultant is unaltered. Okay, unaltered. You have to find one minute. You have to find the value of P. I'll give you a hint. So the thing is that, for example, if we have a force P and 2P at some angle theta, okay, I'm not saying this is 90 degrees, this is just a representation. So P and 2P are two angles, two vectors that are being acted at a particular two vectors that are being acted at a particular point have so condition. In this new condition also, the direction of R is same. This is R dash. Maybe the magnitude will be more than this, but the direction is same. This is what say are saying. So first what you have to do, first you have to calculate the direction related to these two forces. Then you have to calculate the direction, that is tan alpha relation, related to these two forces. And then you have to equate them. From there you'll be getting the value of P. Try to solve it, otherwise I'll do it.
Inside
Any answers? Did you get anything?
Trying, sir.
I'll wait for 1 more minute, then I'll start answering. All right, see here. Anybody, did you solve?
No, sir.
No answers?
No, sir.
All right, see here. The first will be finding the resultant. Let us say tan alpha for the first case, initial case, is what? We are finding the alpha from P vector. So as I said, first of all, I'll be writing sine theta upon cos theta. And then if I'm finding the vector from P vector, I will not be assigning P vector to any of the theta. I'll be writing the other one. 2P here, 2P here, and plus P. Okay. And in the second case, with the increased effect also it will be same. I'm finding alpha from 2P vector. So it is, okay, it was initially P now here. It was initially P. P. Now I'm finding from 2P and this vector is there. So it will be sine theta upon cos theta. It will be 2P plus 20 by 2P plus 20 and plus 2P here. Did you understand this relation? Yes or no? First tell me this. The angle relation. Did you understand it or not?
No, sir.
This is this relation, this one. Which one? This one. This one. The angle relation. If you want to find the angle of the resultant, when we have to find the angle of the resultant, we use this now. Hello, am I audible? See here, in the first case, what was happening here, we had the resultant from P vector and 2P vector. Okay. Then what we had, we increased this P to 2P and we increased 2P to 2P plus 20. Understood? But the direction of the resultant, this was magnitude was more than this, but the direction of the resultant remained unaltered. So what you have to do, you have to equate the direction of this resultant, this is this, with direction of this resultant, because both are same, that is tan alpha. And from there you have to get this value of P. Now will you be able to do this?
Yes, sir.
Do this as homework then. Do this as homework then.
Okay,
And we'll
sir.
be covering the further topics of motion in 2 dimensions in the next class. Alright?
Okay, sir.
Do this.